Hello and welcome back. So continuing on our journey of exploring the solar system, today we're talking about Venus. So Venus is the second planet from the sun, and it is named after the Roman goddess of love and beauty, who is also known as Aphrodite in the Greek mythology. Venus is sort of Earth's twin sister planet. Sort of. They're almost the exact same size. The radius of Venus is about 95% the radius of Earth. Its mass is a little bit smaller. Its mass is about 81 to 82% the mass of the Earth. And Venus has an orbital period around the sun that's about 225 Earth days, or a little over 60% of an Earth year. So it has a lot of things in common with Earth. And unlike, say, Mercury, which had that kind of very anomalous composition with a lot of extra metals, Venus seems to have a composition similar to the Earth as far as its terrestrial components go. However, Venus is like Earth's twin sister that went bad. Venus is often described as hellish, and that's for a very good reason. Venus is in fact the hottest planet in the solar system, even hotter than Mercury, which is far closer to the sun. Its average surface temperature is 737 Kelvin, which is 864 degrees Fahrenheit. Now that's a toasty summer day. And this is due to a runaway greenhouse effect in its atmosphere, which is composed of 96.5% carbon dioxide, which, as we know, is a greenhouse gas. That is, it kind of helps blanket the planet and hold in the heat rather than letting that heat radiate back out to space. And so this is why Venus is just so damn hot. And because of that thick atmosphere, the surface pressure on Venus is 93 bar, where on Earth it's 1 bar. So that's 93 times the surface pressure on the surface of the Earth. The equivalent would be going underneath the surface of the ocean on the Earth to over half of a mile in depth. And that's just standing on the surface of Venus. Oh, and did I mention that atmosphere also has a lot of sulfuric acid clouds, and it's just not nice. So although Venus might be a bit hellish and inhospitable, well, it's still a very interesting planet. Venus is actually the third brightest object seen in the sky from Earth, and the other two are the sun and the moon. So it is basically the brightest thing in the sky that's not the sun or the moon, which is pretty insane when you think about it. This is because it's close to the sun, so it receives a lot of sunlight, and it's close to us, so that light that it's reflecting doesn't have a lot of time to dissipate, and it reflects a lot of light because those sulfuric acid clouds that I mentioned in the atmosphere are very reflective. And so, yeah, Venus is basically this shining beacon in the sky. It's always very close to the sun because it's closer to the sun than us, and so in our sky, it tends to appear close to the sun, and that makes it kind of most visible at dawn and dusk. One thing that's really strange about Venus is the way that it rotates. So Venus is actually what we call a retrograde rotator. So most planets are prograde rotators. That means they rotate in the same direction that they orbit, which would be counterclockwise. Now you might say, okay, on what clock? Yes, okay, you have to pick a frame of reference when discussing the solar system, but once you pick that frame of reference, Venus is backwards, no matter which way you choose it. Also, we generally choose it based on the right-hand rule, that is to say, the planets go counterclockwise and you're looking up. Venus orbits, like all the other planets, counterclockwise, but it spins clockwise, so it's a retrograde rotator. It's also rotating very slowly. So obviously on the Earth, we rotate basically 365 times per year. On Venus, it actually doesn't even complete a rotation in a year. A sidereal day on Venus is actually 243 Earth days. And if you'll recall, we said a year on Venus is 224.7 Earth days. So yeah, very slowly rotating retrograde. Now these two facts, the fact that it's very slowly rotating and it's rotating retrograde, have led scientists to believe that actually it used to rotate prograde. That is, it used to rotate just like all the other planets, but because of this very thick atmosphere that's also causing it to heat up and have this insane pressure, it's also creating drag and on the planet, basically from tidal forces with interacting with the sun and the other planets in this very thick atmosphere, and that has slowed down the rotation of Venus over time, and eventually stopped and started going backwards because of this. So that's the leading theory on why Venus has this very strange retrograde rotation. Because Venus is just so dang bright, humans have been observing Venus for as long as they've been observing the sky. We don't have any earliest really known because it's just always been known. And like I said, because it's generally close to the sun on the sky, it has been romanticized as kind of the evening star and the morning star, depending on, its relative position, whether it appears at morning or night. In fact, some early cultures even thought that the evening star and the morning star versions of Venus were different objects, although they later realized that it was in fact one object. Venus was the first of the planets to have its trajectory across the sky mapped out, which we know happened as early as 2000 BC and probably even earlier. It's just really hard to miss. And when viewed with a telescope, even the very rudimentary, very first telescopes, Venus has very obvious phases like the moon because it's located between us and the sun, and so only portions of it are lit by the sun depending on the configuration. And this, in fact, was one of the very first observational pieces of evidence in support of heliocentrism, because a geocentric configuration would not lead to phases of Venus like that. So phases of Venus was a really important piece of basically making the argument that no, the entire solar system doesn't go around the Earth, it goes around the sun. And while Venus is between us and the sun, it is not exactly in the same plane, and so it doesn't actually transit the sun very often. That is, it doesn't pass directly across the surface of the sun from our perspective. This happens pretty rarely. The last time it happened was in 2012, and I hope you saw it then, because the next time it's going to happen is in 2117. 2117? I don't know how we say dates in the future. Anyway, it is on a very long cycle, and so so transits of Venus are pretty rare. Now, although we have been observing Venus for a very long time, including via telescope, we actually couldn't learn very much about it from those observations because that atmosphere, like I said, it's very reflective and it's very smooth. So basically, when you look at Venus in visible light, you just kind of see a smooth disk, and this was all that astronomers could see until the 20th century and some breakthroughs and advances in observational technology, including spectroscopy, ultraviolet, and radar observations of Venus, which kind of allowed us to peek beneath these dense clouds for the first time. This included spectroscopic measurements that helped us measure the rotation for Venus for the very first time, and our very first look at the surface of Venus, which was achieved via radar using the radio telescope in Puerto Rico called the Arecibo telescope, and that was in the 1970s. So given its prominence in the sky and its proximity to us, Venus was kind of a logical target for some of these very first early space missions. And in fact, there have been 36 space missions targeted at Venus that have been conducted by the Soviet Union, the USA, Japan, and the ESA. And the very first space probe sent to any planet was the Soviets' Venera mission in 1961 to Venus. Now, that mission was unsuccessful, but it was followed in 1962 by NASA's first mission, Mariner 2, which was successful and was able to return images of Venus from space, which was the first successful interplanetary mission in the world. Now, the Soviets sent many, many missions to Venus. It was kind of their goal in a lot of ways. And in fact, as recently as last year, some Russian officials have referred to Venus as a Russian planet because the Russians and Soviets had so much success with their missions there, while the US has been a little bit more focused on Mars. But despite the Cold War space race, the two nations were actually able to do some work together. So in 1968, a combined Soviet-American science team was able to analyze the data from both the Venera 4 and Mariner 5 missions, which were Soviet and NASA missions respectively. Now, most of these early missions were flybys or orbiters, in part because of the extreme difficulty in landing things on Venus. But in 1975, the Soviets did land on the surface. The Venera 9 and 10 missions actually took black and white pictures of the surface of Venus, the first images ever taken on another planet. This was followed 10 years later in 1985 by the first color images taken on another planet by Venera 13 and 14. There was another NASA project called Pioneer Venus in 1978. The ESA sent a mission called the Venus Express, which orbited Venus from 2006 to 2014. And Japan currently has an operational orbiter called Akatsuki that has been in orbit around Venus since 2015. NASA doesn't have any current Venus missions, but it has been examining a lot of proposals for Venus missions and selecting them to kind of move forward in the process, so we're really hoping that there is going to be a Venus mission soon from NASA. Now, I mentioned that there were 36 missions that were directed to Venus, but there were also at least 6 other missions that used Venus for a gravitational assist and were able to fly by and basically get some information as they flew by, including things like the Messenger mission to Mars. It's hard to say. The currently active Parker Solar Probe, which just released some Venus images like a couple weeks ago, and the Cassini probe that ultimately ended up at Saturn. But Venus-specific missions have kind of tapered off as the scientific community shows more interest in missions to places with more accessible surfaces, like Mars. And this is because putting anything onto Venus is an extreme engineering challenge due to those temperatures, pressures, and basically acidic atmosphere that I mentioned. So as you can tell, that would not be easy to put instruments on that can withstand that and operate for any length of time. But like I said, NASA is hoping to go back to Venus soon, and I really hope that we can get some more awesome, interesting data and that people can get as excited about Venus as they do about Mars, because I think they're both wonderful. All right, lastly, let's talk life on Venus, because this has been in the news a lot. Now, I said earlier that Venus is incredibly inhospitable. It's hot, it's acidic, it's high pressure, all of that. It is very inconsistent with life as we know it. However, for a long time, scientists have actually proposed that some of the regions in the upper atmosphere of Venus would actually be habitable zones, basically, for some sort of life if there had earlier been life on Venus, that it could have basically survived in this atmospheric layers. And this became a very hot topic last year after a very unexpected detection of a gas called phosphine while taking test measurements basically of Venus. This team was not expecting to find phosphine in the Venus atmosphere, but they wanted to test phosphine detection because it's considered a promising biosignature for exoplanets. Because as we know it, basically terrestrial planets cannot produce phosphine in significant amounts abiotically, that is without a biological source. It can be produced abiotically on, large planets like Jupiter and Saturn, but not on terrestrial planets that we know of. So when they took this data from Venus, they were not expecting to find any phosphine, but they actually did. And so this was a huge surprise and very interesting because, like I said, there's not really an abiotic source that they could think of to explain it. However, the telescope data that they originally used for this detection, there was an error with it and needed to be recalibrated in some way. I'm not sure of all the details, but basically they had to revise their measurement, and they revised it much lower to basically say that they still detected phosphine, but not nearly as strongly as they had in the original paper. And several other papers came out saying, some of the analysis methods were maybe not robust and that perhaps this detection wasn't really a real thing. So we're not sure if there's phosphine. There may or may not be phosphine in the atmosphere of Venus. And even if there is phosphine, it may or may not have a biological source. It could be some abiotic source that we don't know enough about yet. But in any case, it's a really interesting discovery, and I think it kicked off a really interesting conversation, and I really hope that we get more Venus data soon, and we can do things like measure if there actually is phosphine, or what, just everything about it. I think it's cool. Whether or not there's life on Venus, it's an awesome planet, it's a cool piece of science, and it's a cautionary tale for us because we don't want runaway greenhouse effect, all right? Take a look at Venus. Now, I don't think we're in danger of having a 96.5% carbon dioxide atmosphere anytime soon, but we don't need things to get to 864 degrees Fahrenheit before we are in a bit of trouble. So that's Venus, the morning star and evening star, the second planet from the sun, and Earth's very hellish twin sister. I hope you enjoyed, and I hope you'll come back for, I think we're going to skip Earth, but we'll talk Mars next time. Yeah, thanks so much for watching. Have a good one. Bye.